All right, so in the last video, we went over one microstate and how to use Russell-Saunders coupling to figure out these capital M sub L and M sub S values. So one of these microstates was a 2-electron spin up, one in the 1 subshell, one in the 2 subshell. This is D2 electron configuration. We're trying to solve this problem of vanadium. Remember, it's a hexa-aqua vanadium complex, UV vis spectrum. That's what we're trying to do. I'll remind you that every once in a while because it's going to be so much problem solving that we can kind of forget what we're trying to do in the first place. That's what we're trying to figure out, why there's 3 peaks in the UV vis spectrum of that hexa-aqua vanadium complex. And we're simplifying it to start out as just a V3 plus ion, thinking about the different microstates. So we abbreviate this as 2 plus, 1 plus, because they're both spin up, so that's what the plus means, and those are the subshells of 2 and 1. So what we can do is make what's called a microstate table. And so I put in 2 plus, 1 plus state here that we talked about. Here it is right there. It has a capital M sub L of 3, 2 plus 1, and a capital MS of 1, because 1/2 plus 1/2, both spin up. So now you can say, well, what if you did both spin down? Well, both spin down, you still have 1 plus 2, M sub L of equal to 3, and you have negative 1/2 because spin down, and negative 1/2. Negative 1/2 plus negative 1/2 gives you negative 1, M sub S, capital M sub S, negative 1. So put it in this negative 1, 3 block. Okay, we have 1 spin up, 1 spin down. That's another one, right? Still going to have a capital M sub L value of 1 plus 2 equals 3, but now you have 1/2 minus 1/2, M sub S value of 0. Put it in the 0, 3 block. What about spin down and spin up? Well, that's very similar. It's actually going to be the same set. We just flipped which ones spin up and which ones spin down. And so we still have, an M sub L of 3, M sub S of 0. Keep going. And the key here is just do it in some systematic way. There's no right order to go through these. This is just a problem solving thing. So go through it in some systematic way, right? And so here I put both of them in the 2. Okay, well, if both of them are in the 2, then M sub L is going to be 4, 2 plus 2. But we have a spin up and a spin down, so that's negative 1/2 plus 1/2. That gets me an M sub S of 0. So I put it in the 4, 0. You can see that you can't have 4, negative 1 or 4, 1, because that would violate Pauli exclusion principle, right? We can't jam 2 electrons spin up here, both in the subshell 2, or jam 2 electrons spin down, both in the subshell 2. So those would have the same individual quantum numbers. Those aren't unique electrons. All right, let's keep going. 1 in the 0 spin up, 1 in the 2 spin up. M sub L of 0 plus 2 equals 2, and M sub S of 0 of 1/2 plus 1/2 equals 1. So it's in the 2, 1 here. Spin down in the 0 and 2. That's going to be the same thing, M sub L 0 plus 2. So that's going to be M sub L of 2. But M sub S is going to be negative 1/2 plus negative 1/2 gives us negative 1. So I put it in there. 1 spin up and 1 spin down. That's going to be M sub L 0 plus 2. And 1/2 plus negative 1/2 M sub S equals 0 for that one. What about the first one spin down, the other one spin up? That's going to be the same exact thing. We just switched which ones were spin up and spin down. Keep going here. I mean, it's not hard at this point. It's just long. Okay, let's put both of them in the first subshell. We haven't done that. So that's M sub L equals 1 plus 1 equals 2. And then we have spin up and spin down. It actually ends up being in the same box here because that's M sub S equals 0, spin up, spin down. What about 1 in the negative 1, 1 in the positive 2? That's going to be, well, M sub L equals negative 1 plus 2. That is M sub L equals 1. And then spin up, 1/2 plus 1/2, M sub S equals 1. Same subshell, spin down, M sub L still going to be equal to 1. But now M sub S is negative 1 because it equals to negative 1/2 plus negative 1/2. Spin up and spin down, same M sub L equals 1. M sub S is going to be 0 because they're opposite spins. And then we can do it the reverse way, spin down, spin up, same M sub L's and M sub S's. Keep going here, 0 and 1, both spin up we could do. That would get an M sub L of 0 plus 1. Put it in the 1. And then we have m sub s of 1/2 and 1/2, both spin up. M sub L, again, is 0 plus 1, but now both spin down. So that's going to be negative 1/2 plus negative 1/2, M sub S of negative 1. Spin down, spin up. Same M sub L of 0 plus 1 equals 1, but now MS is going to be equal to 0 because we have negative 1/2 plus 1/2. And so that's here. And then we have spin up, spin down, just changing which one to spin up and spin down. That gives the same M sub L and M sub S. Cranking along here. What about 1 and negative 2 and another electron and 2, positive 2 subshell? And there's 4 different combinations. The spin ups, that's going to give M sub S equal to 1, but M sub L equal to 0. All these are M sub L equals 0, right? So we're going to fill up these 4 states right there. M sub L equals 0 because negative 2 plus 2. Spin up, one of them is going to be M sub S equals 1. Spin downs, M sub S equals negative 1. And then the 2 versions where M sub S can be equal to 0. What about negative 1 and 1? All right, same idea here. All these are going to have MS's, MLs of equal to 0, negative 1 plus 1. And there's 4 combinations. Both spin up, MS equals 1. Both spin down, MS equals negative 1. 1 spin up and 1 spin down, MS equals 0. Those are those 2. Okay, and lastly, we're just missing on this right side of the microstate table, both of them in 0. And when both of them are in 0, M sub S is going to be equal to 0, spin up, spin down, and ML is going to be equal to 0, 0 plus 0. So that's a 0 plus, 0 minus state. We have done here 23 microstates. We know there's 45 microstates total. We've been focusing on ones that are on the right side of this table. But if you go through this, what you'll recognize is that the table is very symmetric. It's all about symmetry, of course, right? The 0, 0s are kind of a middle point, okay? So there's 22 on the right side, 22 on the left side, and 1, the 0, 0 state, the 45th state, is just in the middle of the 0, 0 state. So the table is symmetric. So you can go through this, but it's going to be symmetric. The only thing that's different here is now, you know, here you had 2 positive 2s, here you have 2 negative 2s. Here you had negatives on the left side, here you had positives. Okay, so you can go through that, but it's symmetry. Now that's a quick way, you know, we split the work by half, and so this is our final microstate table. So we found all 45 microstates after some work. And so what we're going to do in the next video is we're going to take those 45 microstates and we're going to group them by their energies into electronic states. These are called free ion terms. Remember, we're talking about atoms. They are free ions, so we're using atomic terms. We're going to use atomic term symbols here, not term symbols for molecules.